So we will now we will go to the next topic, like, which is black box techniques. So structural techniques are mostly it is related to white box testing, which is mostly done by white box tester. It is a code level of testing. It is not a functional testing. So mostly it is done in the code, like statement is covered, branch is covered, etc. Now, black box testing is the real functional testing, which will be done by the software testers, or we call as functional testers, or we can call it as a manual tester, automation tester, etc. So there are different types of black box techniques, but we will cover the most important ones here. One is boundary value analysis, equivalence class partition, state transition technique, cause effective graph, decision table, use case testing. So uh, what is boundary value analysis? First we will see what is boundary value analysis. This boundary value analysis and equivalence partitioning is a very traditional way of doing the testing. So it has been in the testing for quite long time. Maybe in the real time they don't call it as boundary value analysis, or don't call it as using these names like equivalence class partition and all, or one way or other every tester does this boundary value analysis and equivalence class partition. So first we will check what is boundary value analysis. Let us take a small example on that. So boundary value analysis is nothing but, as the name indicates, you will do the analysis with the boundary values. I will repeat it again, like it is like you will do the testing, or if you will do the analysis with the boundary values. So here, for example, we will take it a login screen. So login screen, we will have a username and we will have a uh, password text boxes. So you have a scenario like username should accept only 15 characters, or we can put it as username should accept up to 15 characters, and password should accept up to, or we can keep it little bit more complex way, should accept 5 to 15 characters. We will just take it as example. So, and password should accept 5 to 10 characters. We'll take it in this way. So what is boundary value analysis? So in this testing, we will do like the boundaries of, first if you take username, the boundaries of 15 characters, which is the maximum character. So the tester should test with 14 characters and the tester with test with 16 characters. So why this boundary value analysis? Anyway, we will give a specific number of characters and test the username and password. Why this boundary value analysis is given more importance? Why it is has been made as a concept itself? Because most of the developers make mistake when they are in the boundaries, like when they are writing the code, they make mistake in the boundary values. So 5 to 15 characters, the developers might make a mistake, like he will be allowing until 16 characters knowingly or unknowingly. So if, for example, he might have put a wrong loop, or he would have put a wrong condition which might be accepting more than 15 characters. So developers will most of the cases developers will make mistake in the boundaries. So that is what it has evolved as a concept itself, and it has been given a name in the testing. So many cases what the developers is do is like the requirement document will be written as username should accept 5 to 15 characters. The tester will miss the 5. I mean the developer will miss the 5. What he will do is he will just write the code for the username to accept until 15 characters. So what happens if you give username as 4 characters also, it will accept, and that is not satisfying the requirement. So the test is fail. Or if you miss that in test, it is a big issue in the production. So most of the developers makes mistake on the boundaries. That is the reason this boundary value analysis came into picture. And so what will be the boundary for username is you should give the input values as 14 and check whether it is working or no, and you will give the input values as 16 and you will be verifying whether it is working properly or no. Again, as we have said as 5 to 15 characters, now there will be two more boundary values. What are those? You will be giving 4 and you will be giving 6 for the minimum. So this username is for maximum accepted characters, and boundary value analysis for minimum is minimum accepted characters. So this is how they do. So as I said, many developers will miss doing the boundary analysis, like they make mistake mostly on the boundaries. So this boundary value analysis is very important in any testing. So this is how they will do, like what are the values in the boundary, like 14 and 16 are the boundaries of 15 and 4 and 6 are the boundaries of 5. So they do that. So only these two values they do, like boundary value analysis only 14 and 16 they do and they stop. Yes, you, if you wanted to do exhaustive testing, you can also give one more -2 and +2 boundaries, like you can give here 13 and, but actual boundary value analysis is like only the boundaries which is nearby values. So but you have time, you wanted to do a exhaustive testing, like you wanted don't want to miss any bugs. So for example, and in some scenarios what they do is, like some looping is wrong or some coding having problem, it will not accept 16 characters. For example, 15 is the maximum number of characters it should accept. It might not be accepting 15 characters, but what will happen is some will be accepting 760, it will be accepting 15 characters and it will not be accepting 16 characters. In some cases what will happen is it will not accept 16 characters, it will accept 17 characters if the developer has written the code wrongly. So if you want, so all the possible scenarios are not possible, like you can assume anything and you can do many number of infinite number of testing on this. So but if you have time and you are ready to do some exhaustive testing, some will have a testing boundary value analysis for testing for 13 as well as 17 as. So we can make it like this: 13, 14 and 16, 17 also you can do if you have time. So you will think like why it is like there is no time, there is the just four verifications. So this is not this, we have taken a simple example of login screen, there is only two edit boxes. There will be hundreds of text boxes in an application, hundreds of validation in an application. So you cannot sit and do all the hundreds of validation with the different values, or you cannot make four boundary value analysis for each text boxes. It consumes lot of time. So normally if the time is less, they will make only two boundary value analysis, which is very near to the maximum and minimum values. So here username minimum acceptance character, if you want you can include 3 as well as 7 also. So this is not mandatory, you can do it. You can include one more also. So here password, again what is the boundary value analysis? Password maximum is 10 characters, so maximum, so your boundary value analysis will be 9 and 11 and minimum will be 4 and 6. So if you want you can include similarly like 3 and 7 as well, same like that. And here obviously 8 and 12 as well. So here one important question is like, so you are saying like it should accept 5 to 15 characters. What kind of testing you will do for boundaries? For us of now, we will remove this 13 and 17. So these two are the main boundaries. So what kind of testing you will be doing here? It should accept 14 characters should be accepted and should throw error message, whatever error message which is described in the requirement document, should throw error message as it exceeds the maximum number of characters. So this should be your testing. So similarly for this, 4 should be accepted and 7 should be rejected, and it should display a error message. I mean, sorry, if you make boundary, it is 4 and 6. So 4 should be accepted and 6 should be rejected. So this is a boundary value analysis testing. So it is very important for any validation in your application. And boundary value analysis is not only the number of characters, etc., etc. The boundary value analysis can be used for anything, like only not for maximum number of characters. They say like in one page, uh, I mean in one list box, you should be able to add a value into a list box. So if the requirement is like you can add 5 values in the list box, so there is a list box, or you can call it as a drop down or list box, whatever you can call it as. So you are saying like 5 values whenever you are adding a names, for example name, visual, second name, path, etc., etc. So you have a list box or drop down where you can add 5 values. Whenever you are adding a name, it should automatically come in the drop down. So in that case, what happens? 5 values it should accept. You can test like 4 values you will give and 6 values it will give, and it should not get added in the list box. So you can use this boundary value analysis in many number of ways. And then next one is equivalence partitioning. Equivalence partitioning. It is like the concept partitioning. So this concept is not almost similar to boundary value analysis. We can say the concept is more or less the same. So boundary value analysis is like on checking the boundary. Equivalence partitioning is something like very generic way of testing. Like you can, we will take the same username and password as an example. So how equivalence partitioning is done is username. It will accept 5 to 10 characters. So if we keep maximum, your testing will be 10, 15, 20. You will give, okay, it is 10, sorry. You will give 10 characters, you will give 15 characters, and it will give 20 characters. So as you can see from the name, like it is equally partitioned, that the test data or the data what you are giving for testing should be equally partitioned. So it should be in the middle of the previous one. I mean, it will be like normally they take it as 5 numbers less than the value and 5 number letter greater and the value. So it will be equally partitioned data you should give for that. So maximum of this username in equivalence partitioning will be, it will 15 characters. So equivalence partitioning test data will be 10, which is middle of this. I mean, next before this 15, 20. So if you wanted to enlarge, as I said, like you have time and you have want more precise testing, then you can use as 25 as well here. And there is no use of using 5 here because the 5 will come equivalence partitioning with the minimum value. So here if it is 50 instead of a 15, then your equivalence partitioning will be like a more 45, 50 and 55. So here you can enlarge this equivalence partitioning to 60, and you can make it this as 40. Even you can continue this, or some make equal. It is all very like as per your requirement how you want. So some make equivalence partitioning something like 50. If the values are very large, the intervals of values are very large, then you can make it as 40, 30, 20, 10, etc. Something like this you can make it. So equivalence partitioning is like you will give a equal difference between the values you will give, and you will check the application. So what will be the password if it is 5 to 10 characters? Equivalence partitioning will be 15, 5 and 1. Okay, should be very careful in that. The difference will be mostly 5. Okay, sorry, it is not 15, it is 10. 10, 5, 5 will the minimum. If you take it as minimum, 5 is the minimum accepted character. So 5, you will give 10 and you will give 1 and check the equivalence partitioning. Okay, so this is equivalence partitioning. Again, I'm repeating, equivalence partitioning is like equal partition of data we will give. So the partition is equal. See, when I'm giving 40, 30, 20, 10, it should be 1. So the partition is equal. So as per the minimum accepted input data and maximum accepted input data, you will select the equivalence partitioning. So when you are doing equivalence partitioning like 40, 30, 20, 10, then this should be 10 to 50. Okay. So when you are giving 5 to 15, your equivalence partitioning should be 10, 15 and 20. So the difference of 5 or 10 or difference of 20, it depends on how your requirement is. If the requirement values or accepted data is huge, you decide you can have the difference of 20, but the difference should be same, and as per that you have to design. So I will take, to be more clear, I will take one more. You take it as 100 and you take it as 10. So 100 also we can make 10 10 very easily. You make it as 1000. So equivalence partitioning you can make it in any way, like you can make here 100, 200, 300, 400. No, you will not mostly have a text box or equivalence partitioning testing for 1000 values. There will be no text box which will be accepting until 1000 values. So this is just an example to show like equivalence partitioning, how you should segregate the equivalence partition, or how you should use the equivalence partitioning. So in this case you will put as 500, 1000 and 1100. Okay, so you can give the equivalence partitioning like this. If you want a exhaustive testing, again, if you are have a less testing, how it will be like 1000, 900, 1000, 1100. So how the difference is here 100, here 100. So that the data should be equally partitioned. So that is what I was trying to say. Here if you see the data is equally partitioned, 10 and 5. So this is equivalence partitioning. Next is the state transition technique. So it is also the same, almost the same, not almost the same. It is also a similar testing methodology like boundary value analysis and equivalence class partition. State transition technique, many doesn't use it in a right, I mean, in a larger way. So here I have captured for you. The state transition testing is nothing but that the testing will be carried out with finite number of input values. Like there will be a input when there is going to be a testing. They will design the input values first itself before the testing starts. They knows that this is what is expected from this application or this specific part of the application. So the tester will define some input values, a finite number of input values. There will be many number of input values, and he will be testing using that. So the next line, when the tester is trying to test sequence of events that occur in the application at test. So normally the state transition testing is something like, it will be okay. If you come with an example, for example, you take it like, first we'll say the example, then I will come to the definition to easily understand. So you are going to a ATM and you are withdrawing $1,000. So you have put the ATM card, you withdraw the ₹1,000 or $1,000. Now you have withdrawn ₹1,000. So you had balance of only ₹1,000 or ₹1,100. Again, you are inserting in, you had the balance, you withdrawn the $1,000. So your balance is only 50 rupees or ₹100. We will keep it as one example, like ₹1,100 you have in your ATM, you have in your bank account. You put your ATM card and you withdraw ₹1,000. So your balance is ₹100. So again, you are putting your ATM card and you are trying to withdraw ₹1,000. So what will be the what will be the result? The result will be the ATM will say like, you don't have sufficient amount to withdraw this particular amount. You don't have sufficient amount in your account to withdraw this ₹1,000. So here if you observe, the first is, there is same testing. You are doing this withdrawal testing in your application. Like you are withdrawing ₹1,000. That is the testing. So you can keep it as you have transferred ₹1,000 from your account to a different account. So you have ₹100 in your account. Again, you are trying to transfer from one account to another account ₹1,000. What the application will display? So that will be a better way of understanding. The application will display there is no sufficient amount in your account to do this transfer. So you cannot transfer the ₹1,000. So here it is the same kind of testing. What you have done first, also you have transferred ₹1,000 from your account to another account. Second time also you are doing the same scenario or same testing or same thing you are doing, like you are transferring again ₹1,000. So here what happens? The first time when you are transferring ₹1,000 has happened. Second time it should reject and send you an error message. So the testing is same. You are doing the same testing or you are doing the same work. Like you are transferring ₹1,000 first time also, you are transferring ₹1,000 second time also. But first time it should approve and it should go through. Second time it should reject and send you an error message. So this is a state transition testing. Like you are doing a same set of testing, but the events that output or that is how it is the application should transition, the application transition should happen from one level to another level. So for example, I can say, so what happens here is ATM, ₹1,000 you have in your ATM. First scenario, second scenario. So in first scenario you are transferring 1,000 to one account to another. You can keep it as transferring 1,000 from account 1 to, this will be more clear, account 2. And what will be your second scenario? Your second scenario is also same. That is what very important to note here. Your second scenario also is same. You are transferring 1,000 rupees from account 1 to account 2. Same account, same everything. So, but you have this 1,000 rupees balance in your account. So, in first scenario, test case should pass. But second scenario, test case should fail. So the application is the same. So anyway, the developer would have written a code like when you are doing 1,000 rupees in first, the code will be almost the same. When you are doing the first scenario, he will go and he will have a condition. That is what a conditional statement testing we have learned before this in white box testing. Here is how the conditional testing is very important. So if he didn't put the condition very properly, then second time also without any balance, the transfer will happen. So that is very important. Okay, coming to our point in state transition testing. So the developer will again go to here, he will check the balance and he will come and he will approve this. I mean, the application will approve this transfer. Second time, it is the same scenario. It will go and check. That time balance will be 0. So here, if we can put 0 balance, it will go and it should throw error message. So here, what is happening is the system or the application. See here, it is called. It is written as state. Okay, here the system. You can call it a system transition testing. Also, this one. So here, what this application is doing is like it is transferring its state, or you can tell that it is transition is happening from the for the application. The transition, you know what is mean by transition is happening from one form to another. To be noted, transition of the application is happening one form to another form. So for first scenario, it should go through. For second scenario, it will not go through. So the application is transition is happening in the application. So this kind of testing is called state transition testing. So now if you go to the our PPT, you can understand. So when the tester is trying to test sequence of events that occurs in the application under test, that is, this will allow the tester to test the application behavior for a sequence of input values. So when the system under test has a dependency on the events or values in the past. So here what is it? The dependency of this scenario is having, there is a dependency of this scenario on first scenario, or these scenarios values have a dependency on this first scenario. Second scenarios have dependency on the first scenario values. So that is what it is meant here when the system under test has a dependency on the events or values in the past, or I can say yes, previous scenario. So here what it is saying, the tester will be testing a sequence of events. So events is nothing but first scenario you are withdrawing cash, second scenario also you are withdrawing cash. It's a sequence of events. So in that sequence of events, how the application is behaving is called state transition testing. So this is what state transition testing is.